When the facts bend reality, this is beyond plausible.
The deep sea can be a lonely place, its dark expanse seemingly desolate. Life here appears sparse and isolated. However, deep-sea biodiversity is not absent. They rely on interactions among these bottom-dwelling creatures to survive. Whether it's symbiotic organisms, scavengers, predators, or parasites on hosts, there is an ecological interaction that brings richness and impacts organisms to promote diversification. These play a crucial role in the success of deep-sea biological communities. This video takes a closer look at competition in the deep sea and how it shapes the unique ecosystem and its fascinating inhabitants. Surviving in the deep sea is a huge challenge. Here, oxygen levels and nutrients are dangerously low. Organisms struggle to obtain adequate resources. As a result, conflicts between species competing for the same resources in the same place are inevitable. In other words, competition here is fierce. Animals across the ocean belong to different trophic levels in the food web. These are the levels in an ecosystem. Each tier consists of organisms with similar feeding behaviors, whether producers, predators, or prey. This is important because much of the competition in the underwater world occurs between animals of the same trophic level. For example, sharks compete with other top predators like moray eels. Both need ample space and similar prey to eat. Herbivores also compete with other herbivores to secure the most valuable food portions for themselves. Even plant-like species compete with each other to attract the most sunlight. In shallow waters, this type of competition can lead to great biodiversity. Simply because nutrients and other supportive resources in this area are extremely abundant. But in the great depths of the open ocean, the area's resources are very limited, meaning only a few ecological niches can exist. These ecological roles and suitable lifestyles are occupied by some species, and only a few of them are capable of surviving in the deep sea, so there is greater competition among different species trying to fill the same position. This explains why the deep sea has so much competition, as organisms must share a fragile ecosystem with many competitors. All are trying to consume the same limited resources, but competition doesn't always arise in one way. In fact, it has two different forms. First is interspecific competition. This occurs between members of different species. The second form is intraspecific competition, occurring among members of the same species. Some of the most typical deep-sea communities exhibiting interspecific competition are found at the very bottom of the ocean. In areas between deep trenches, space can be quite comfortable for the living communities there. But the lack of food or hiding places means their chances of survival are very low. So, to solve the problem, many organisms gather in large numbers around certain active hotspots. These could be the carcass of a whale fall into the chemical-rich brine pools, or hydrothermal vents with extremely high temperatures. These are places where some life-sustaining energy sources can be found. These ecosystems are considered to have high species richness at the ocean floor. But the rocks here are also places with too many competing organisms. All of them try to secure the best position or gather as many resources as possible. This has led to the formation of symbiotic communities, allowing organisms to coexist comfortably with other species while relying on them for survival. But this is only the case when organisms gain something from each other. For example, at hydrothermal vents, giant tube worms rely on energy produced by chemosynthetic bacteria to convert chemicals in the water into nutrients. Another species is the yeti crab, which also relies on the same bacteria for similar reasons. So, while there may be symbiosis between animals and bacteria, there is also competition between crabs and tube worms for space on rocks and ownership of bacteria. This is also a typical example of interspecific competition. Not only do tube worms and yeti crabs compete for the same bacteria, deep-sea shrimp, mussels, or squat lobsters have similar ecological niches. And thus, all compete for the same resources in the same place. Often, interspecific competition can lead to the extinction of one of the competing species. Less adapted organisms may not compete for necessary resources, meaning members of that species are less likely to survive. They gradually become less competitive in an ecological niche. This is because species with similar niches also have similar needs. The hypothesis states that in a stable ecosystem, no two species with the same habitat and food source can coexist stably. This is called the competitive exclusion principle. But when this doesn't lead to extinction, instead, interspecific competition causes specialization in each different animal species. This phenomenon is called resource partitioning. In it, species with overlapping basic niches evolve different adaptive abilities. It helps all species coexist because there is less direct competition between them. This is what happened at hydrothermal vents to make the biological communities there stable. Competing species like crabs, shrimp, and worms may pursue the same resources, but they have developed very different ways to get what they want. As a result, each of these organisms uses only a portion of what they could potentially use if they were the only species in the ecosystem. Let's see how these animals have changed to coexist. Jetty crabs cultivate bacteria into filamentous colonies on their bodies, reducing spatial competition pressure with other species like shrimp. These crabs can move around and carry the bacteria with them. In contrast, tube worms have no legs, meaning they are fixed in place and cannot move. This species' competitive advantage comes from storing bacteria in their tubes, keeping them efficiently and benefiting from the nutrients produced by the bacteria. Another resident of deep-sea hydrothermal vents is the Pompeii worm. They cultivate bacteria in a similar way to jetty crabs. But this doesn't cause much competition, as their habitat is right next to the vents, where temperatures are much hotter than crabs can tolerate. In a way, worms and crabs have become behaviorally isolated from each other. The different adaptations and behaviors of these organisms allow all to share the bacteria without encroaching on each other. So, unlike vast deep-sea areas where low resources lead to low diversity, at hydrothermal vents, abundant resources allow the ecosystem to be diverse due to competition driving species to specialize in different ways. In the deep sea, conflict between individuals of the same species is the most common form of competition. This is because large distances and depths lead to geographical isolation of competing species, reducing competition as they migrate to different locations, where they can occupy the same position without disturbing each other. But for members of the same species, conflict is unavoidable. Whenever animals here compete for territory or try to attract potential mates to fulfill their reproductive mission, they must compete. Group hunting techniques demonstrate that interspecific competition is a fundamental factor in natural selection. At night, groups of Humboldt squid up to 40 individuals swim up to hunt lanternfish schools, although they are cooperating to hunt. But they are also directly competing with each other. Stronger and faster individuals are able to eat more fish. In fact, they are also known for their cannibalistic habits. Larger Humboldt squid will hunt smaller members of their own group. In a clear demonstration of survival of the fittest, this leads to evolution for better adaptation within the species. Because individuals with favorable evolutionary traits will have better competitive chances and higher reproductive success than their rivals. In other words, the strongest are the ones who survive and pass on their genes to the next generation. Competition is an important aspect of the deep-sea ecosystem. Many facets of the ecosystem are affected by these interactions. How animal species compete with each other determines their distribution, as well as community structure, food webs, and population fluctuations. And over time, these interactions lead to behavioral and physical adaptations in species, contributing to their evolutionary process. On the seafloor, resource partitioning allows many organisms to share an ecological niche. In a similar way, geographical isolation in mid-waters allows numerous marine residents to coexist. Together, these processes and principles demonstrate the importance of competition for deep-sea biodiversity. And are you impressed with the deep-sea residents? Please leave your opinion in the comments section below.
Curious? Subscribe and step through the next anomaly.